continuous topic of electrostat. Electrostat. Electrostatic. Okay. Now, you see, more very important. I'm going to explain very important topic. That is okay. That is two small balls, two small spheres, speed of masses, and masses are two small speed of masses are suspended from with the help of from fixed point, a fixed point with help of string, each length of L, which two small speed of masses m, each mass m or two small speed of masses each m are suspended from a fixed point with the help of a string, each length L. Charge Q is given to them each charge. Then so find distance between two charges. So this is a two small speed of masses each m are suspended from a fixed point with the help of string, each length L. Charge Q is given to them and find the distance between two charges. So, black. Now, this is a rigid body. Now, this is a rigid body. This is a string number one. This is a bob. This is another string. This is a length of the string is L. And this is having mass is m. This is having mass m, and charge is Q, and Q mass m charge, and this bob having m charge. Now distance between two charges is x. This is initial position of the two bobs. Now here distance between here is x by 2, here also x by 2, from here to here. That's right. Now this is angle is theta, this also angle theta, both are theta theta here. Now, so this is a two small sphere of masses. This bob having mass m, this bob having mass is m, are suspended from a fixed point. This is a fixed point. String of each length is L. This is a string, length is L. This is another string, length is L. Charge charge Q is given to them. One charge is given to small bob M. Another charge they also given to another bob, and find the distance between two charges. Find out the distance between two charges. We have to find out the x value. We have to find out the x value. Now you see, this is a positive charge. This is also a positive charge. This positive, both are what type of charges? Two charges are like charges. Like charges repulsion each other. This is electrostatic force. The charge will repel to the charge is this direction, that is electrostatic force. Now the charge also will repel to the charge is this direction, that is the electrostatic force. Now, so this way having the tension, double side tension. Now this is this bob having weight, that is weight at vertically downward direction, that is mg, weight at vertically downward direction. This bob having mass m and gravity g, this is the weight of the bob. This is axis, I think this is x dash, this is y dash. Now this is a making angle theta here, so this is alternating angle, this is a theta, now this is a t can be resolved into two components. Making angle theta means this is a t cos theta, this is a t sin theta. Now the bob is at equilibrium position. Now, so bob is equilibrium condition. Now we can take horizontal side forces. This is a Fe force. Fe force pulls the bob is this direction. Now T sin theta is a tension component, nothing but force. This force also pulls the charges this direction. Both are equal and opposite direction. Both forces are equal in the equilibrium situation. T sin theta is equal to Fe. I am going to write. This is equation number 1. Now horizontal direction forces are completed. Now vertical forces. This is a charge. This is a weight. Mg means weight acts vertically downward direction. This weight pulls the block downward direction. This weight pulls the charge downward direction. Now same time T cos theta, I will say one more force. T cos theta pulls the charges upward direction. Both are equal and opposite direction. The bob is rest. That means equilibrium condition. Now equilibrium condition means now T cos theta is equal to and mg. Now we call this is a equilibrium condition. And so here bob is at rest. Now I'm going to write in this equation. Okay. So divide the two equations. So what will happen? 1 and 2. 1 by 2. T cancel. Sin theta by cos theta. I'm going to write to tan theta is equal to Fe by mg. But I'm going to write. Next term, you see the Fc is equal to mg. Take the side mg tan theta. For small angle, for small angle, so what will happen? Tan theta is equal to sin theta. I'm going to write tan theta is equal to tan theta is equal to sin theta. I'm writing now. You can write that his equation FC is equal to mg tan theta is equal to sin theta. For small angle, tan theta is equal to sin theta. Now you can write here sin theta. FC and mg sin theta. FC means electrostatic force between the two charges. FC means electrostatic force between two charges. Two charges, 1 by 4 pi epsilon naught medium between the two charges, and q into q square. Distance between the two charges is x. That is, I'm going to write x square mg sin theta. You can write sin theta. You can take any one triangle. Sin theta means opposite side. This is opposite side. X by 2 hypotenuse, that is a 2l. This is a sin theta value. Sin theta value is sin theta is equal to x by 2l. That is a sin theta value. Now I want this x square value. I want x square, take this side. Okay, so now 2l q square. This 2l take this side. Now 4 pi epsilon naught mc take this side. Now you are getting x square into x cube. That is a x cube. X cube take this side. 2 ones, 2 cancel. 2 cancel. X cube is equal to q square L by 2 pi epsilon naught mg. Now this 3 take this side. 1 by whole power of 1 by 3. This is a distance between two charges. That is a distance between two charges. Distance between two charges. This is a very important. Very important. You see, ma, here, two small sphere of masses m. This is one bulb. That bulb having mass m. This is another bulb. That bulb having mass m. Are suspended from a fixed point. Suspended from a fixed point. With the help of the string. This is a string. This is one string. This is another string. This length of the string is L. This length of the string is L. Charge Q, and one Q is given to the one bulb. Another Q is given to the another bulb. What will happen? Both are repelling each other. And now find the distance between two charges. This is one charge. This is another charge. Distance between the two charges x. This x value is x is equal to q square into L by 2 pi epsilon naught into mg whole power of 1 by 3. Your answer is that one. Now, so what will happen in this situation? You see clearly. This is a positive charge. This is another positive charge. Both are like charges. Like charges repel each other. The charge moves this direction. The charge also moves this direction. Both are moving away from the charges. Both are moving away from. And in the positive charge, this is another positive charge. Both are repel each other. The charge moves this direction. This charge also moves this direction. Now, next, this is a T. T can be resolved into two components. This is a T. Here make an angle theta. Here also make an angle theta with the vertical. Okay. So this is a T can be resolved into T cos theta, T sin theta. This is a Fe. Now the bulb is in equilibrium condition. In equilibrium condition means horizontal forces are equal and vertical forces are equal in the equilibrium condition. The bulb is in equilibrium means horizontal forces are equal and vertical forces are equal. Horizontal forces T sin theta is equal to Fe. The bulb is rest position. The bulb does not move. And vertical forces are equal. T cos theta is equal to mc. The bulb is rest position. The bulb does not move. That means the bulb is rest position. The bulb is equilibrium means the bulb is rest position. Now T cancel each other. Sin theta by cos theta means tan theta. Fe by mc. Okay. This mc take this side. Fe is equal to mc tan theta. For small angle, tan theta is equal to sin theta. Okay, Fc is equal to mg, and tan theta is equal to sin theta. Tan theta is instead of sin theta. Fe means coulombs. Fe means force between the two charges. Force between the two charges. 1 by 4 pi epsilon naught, medium between the two charges, and q into q square, and the distance between the two charges x square is equal to mg, and sin theta means you can apply the sin theta. Theta is opposite side. This is x by 2, and I put in as L. X by 2L. Sin theta value is sin theta is sin theta is equal x by 2L value. Now this is x squared, this is x. X squared take this side, x squared into x cube, and mg take this side, 2L take this side, 2L by q squared by 4 5 epsilon naught mg. 2 ones to 2 cancel. Now x cube is equal to, I mean, q squared into L by 2 5 epsilon naught mg whole power of 1 by 3 your answer. This is a distance between the two charges. Distance between two charges. That is your value. That is your value. Okay, clear? So next term. This system is this system is in air. This is entered. This system is in air. Suppose, for example, now, so this is in air. In air. Here air is present. Air is present. Now, this experiment is placed completely in a liquid. Completely in a liquid. Suppose this is a liquid. Suppose this is air. This is air. Fc is equal to what I'm going to write, mc tan theta. This is in a air. Air. Now this experiment, Yabo experiment, this experiment, Yabo experiment is placed completely in a liquid. Yabo experiment is placed completely in a liquid. Liquid. So find the dielectric constant of consisting of liquid. Consisting of liquid. This is experiment. This experiment is in a air. This is air. This experiment in a air. Now Fe is equal to mg tan theta. Yabo experiment is placed completely in a liquid. Find dielectric constant of liquid. That is very, very important. For this one, now next experiment, same experiment. This is a bulb. This is another bulb. This is a double set tension. This is a weight W is equal to mg. This is resolved into making angle theta. This is resolved into two components, T cos theta. This is a T sin theta. This is Fe force. Now this is charge is Q. Here else Q. Distance between two charges is x. From here to here is x by 2. Here to here is also x by 2. This is the length of the string. This experiment placed in a liquid. placed in a liquid, placed in a liquid, placed in a liquid. So what will happen in this situation? Now, already I told you very clearly, so many examples I explained in the first year. Fe is equal to mc into 1 minus dl by ds. Here mc means weight. Mc means weight. Now dl means density of liquid. ds means density of bulk. Density of bulk. Now totally I'm getting two equations. One is Fe is equal to mg tan theta in air. Fe is equal to mg into 1 minus dl by ds in liquid. Now you can take a liquid. Now tan theta is a constant, remove that one. Now tan theta is a remove. Now you can write it, this is a Fe is equal to mg. You can remove this tan theta. Y means small angle, remove it. Next, divide the equation 1 and equation air by liquid. Fe cancel each other, mg cancel each other. So Fc, now wait 1 minute. Wait 1 minute. Now what I'm getting? Fc is equal to now Fe. This is a vacuum I'm writing. This is a force, electrostatic force in a medium is a vacuum. That is a mg tan theta in air. Now Fe is equal to, I'm going to write mg tan theta, I'm removing here, that is air. Now next, this is a Fc force in a medium, in a liquid. That is I'm writing Fm. Fm means M means medium. Here V means vacuum. Vacuum means here air. This is a V means liquid. Sorry, air. Next M is equal mg into 1 minus dl by ds. Now this is a liquid. Now divide the two equations. Mg cancel each other. Fe by Fm. Now you can write it, this is a dielectric constant K. Dielectric constant K indicates dielectric constant is equal to Fe by Fm is equal to 1 by dl by ds. Now simplify this equation. ds take LCM, ds minus dl. Now this is a Fe by Fm is equal to K. Now K is equal to Fe by Fm is equal to ds by ds minus dl. Now your answer is this. Your answer. This is experiment. This experiment placed in air. Fe is equal to mg tan theta. Now you can write Fe is equal to mg. Now this experiment is placed in a liquid. Now you are getting Fm is equal to mg into 1 minus dl by ds. Mg means weight, dl means density of liquid, ds means density of bulk. Now, so we have the two equations. This equation is belongs to experiment in air. This equation belongs to experiment is placed in a liquid. Now you are getting two equations. Now divide the two equations. Fe by Fm means that is dielectric constant, relative density, relative permeability, and a specific inductive capacity. K is equal to Fe by Fm is equal to 1 minus dl by ds. Now simplifying, and K is equal to Fe by Fm is equal to ds by ds minus dl. Now your formula, that is one formula, that is K is equal. Now next situation. Next second one. Now next, note the point, note this is a rigid body, this is a charge is Q, this is a charge is here, charge is Q1, this is a charge is Q2, that is Q1, Q2. Now this is a angle is theta 1, here angle is theta 2. Distance between the two charges is x. This is, I'm taking x1, this is a x2. I'm taking. Now, this is the condition Q1 less than Q2. Q2. If Q1 less than Q2, that means x1 is equal to x2. x1 is equal to x1 is equal to x2. Now, theta 1 is equal to theta 2. This is a very, very important. Next, number three. Experiment before experiment. Before experiment is taken into space. Experiment is taken into space. What will happen? Gravity. So what is the gravity in the space? Is equal to G is equal to 0. Now, so what will happen in this situation before experiment? Now, before experiment means this is a charge Q. This is also charge Q, and the distance between two charges is x. This is a vertical position, initial position. Now, length is L, here also L. What will happen in this situation? Two charges, this is a charge Q, this is another charge Q. Now, both are in a straight line. So, y means theta is equal to 180 degrees, 180 degrees. There is no weight, there is no weight. There is no weight. Suppose, for example, I'm taking, okay. Now, I'm taking above experiment. Now, initially the charge is Q, and this is a charge also. This is a distance between. Mass is also m also. Distance between the two charges is x. X. Now, this is a angle theta. This is also angle theta. Now, m1 is equal to m2 is equal to m1 is equal to m2 is equal to m means theta 1 is equal to theta 2 is equal to theta 1. Keep in your mind this part. Now, I'm going to explain next third case. Now, this is a weight W is equal to mc. This is a W is equal to mc. This experiment is taken into the free space. What is the gravity? That is 0. W is equal to gravity 0. Weight is equal to also 0. Weight is equal to also 0. Now, what will happen? Gravity is 0. This bob moves upward direction. This bob also move upward direction. This is a fixed point. Now your bob is at this position, length is L. Another bob is at this position, length is L. Length is L. Now, so this is a string having double side tension. This side also having double side tension. Double side tension. Now the charge, this is positive charge, this is another positive charge. Two charges are like charges. Two charges are like each other, repel each other. This is a repulsion each other in a opposite direction. Opposite direction. Now the charge is in rest. Charge is at rest, or Q is equilibrium. Equilibrium means charge is rest. Now when it is Q is equilibrium or Q is rest, when it is rest, Fe force is equal to tension force. Fe force is equal to tension. Tension is equal to Fe. Fe means what is Fe? Electrostatic force between the two charges. Medium is 1 by 4 pi epsilon naught. Charge Q into Q squared. Distance between here from here to here is total length is from here to here is how much length? 2L. 2L. From here to here is L. From here to here is L. Total length is 2L whole square. Now T is equal to 1 by 4 pi epsilon naught Q square by 4L square, your answer. Theta is equal to angle is angle between the two charges is 180 degrees. Angle between two charges. Angle between the two charges is theta is equal to 180 degrees. Theta is equal to 180 degrees. Now your answer is okay. Your answer is that one. Next. Now, next, let us consider two. Let us consider two small ball of masses M1 and M2 having charges Q and Q2 respectively are suspended from a fixed point by using string, with the help of this string. Both are suspended from suspended with help of two strings with same fixed point, with the same fixed point, with this point fixed point. Now now so what is discuss about this discuss 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 about charge equilibrium position. Charge equilibrium position. Equilibrium. Let us consider two small ball of mass m1, m2 and having charges q1, q2 are suspended with the help of two strings with the same fixed point. Discuss about charges charge equilibrium position. Equilibrium. Now let us consider two small ball of masses m1 and m2 having charges q1 and q2 are suspended with the help of two strings with the same fixed point. Discuss about charge equilibrium. Now this is that is a rigid body. Now I'm taking this is a one string, this is another string. Now both strings are in a, this is a string number one having both mass is m1. This is another bob mass is m2. Now first bob having q1 charge, second bob having q2 charge. But q1 and q2 charges are like charges. Like charges repulsion each other. Now what will happen? Now this is a m1 and q1 charge. This is a m2 and this is a q2 charge. Distance between two charges is now I'm checking. This is the initial position of the two charges. Equilibrium. Now from here to here is this is I'm taking x1. From here to here is now I'm taking this is x2 distance. This is angle is theta 1. This is angle is theta 2. Now I'm taking. Now conditions. Condition number one: if m1 is equal to m2, two masses are equal. This bob having m1. This is another bob having mass m2. If m1 is equal to m2, so what will happen in this situation? Masses are equal. So theta 1, theta 2 also equal. Angle also equal. Theta 1 is equal to theta 2. Now, if m1 less than m2, now then angle is theta 1 less than theta 2. If m1 less than m2, theta 1 greater than theta 2, now your conditions. This is very, very important. You see here carefully. Let us consider two small ball of masses m1 and m2 having charges q1 and q2 are suspended with the help of two strings with the same fixed point. Discuss about the charge equilibrium position. M1 if the condition m1 is equal to m2, theta 1 is equal to theta 2. If m1 greater than m2, theta 1 less than theta 2. If m1 less than m2, theta 1 greater than theta 2. Your answer is no. That is no. This is a very, very important topic. Keep in mind. Okay, next topic. I recall all points once again. Now, you take the next problem. You'll see this is a hexagonal. Here each corner having charges. This corner having Q. This corner having charge Q. This corner having charge Q. This corner having charge Q. Here also Q. Here also Q. Now, resultant force acting on the charge. Resultant force acting on this corner and Q naught. So what is the resultant forces acting on this Q naught? Now let's find out Q naught. Now you see distance from here to here is L. Here also L. Here also from here to here is L. You can take L. From here to here is distance is this is root 3L. Root 3L. From here to here is distance is 2L. From here to here is distance is root 3L. From here to here is distance is L. I'm taking. Okay, you see, this is a positive charge. This positive charge. This is a fixed, but this is just moving. This is a freely. The charge is free. This is a fixed charge. The charge will repel to the charges this direction. That is a F1 force. F1 force. Apply the Coulomb's inverse law. F1 is equal to and K and mean between the two charges Q into Q squared by distance is L squared, that is F1. Now next this is a Q and this is a Q and distance between the two charges root 3L and Q into Q squared. This positive charge will repel to this positive charge is this direction. That is F2 force. F2 force. Now apply the Coulomb's law. F2 is equal to K into Q squared by distance is root 3L whole squared. Now we can write F2 is equal to K Q squared by 3L squared. That is F2. Now this is a Q. This is Q. Distance between the two charges is 2L. This positive charge will repel to this positive charge is this direction. This is F3. Now F3 is equal to K into Q squared by distance is 2L squared. Now you can write F3 is equal to K into Q squared by 2L whole squared. 2 squared means 4L squared. Now get right. Now this charge. This positive charge will repel to the charge. Now remaining charges all are absent. Each charge ni repel chestuni ee direction. This is I'm writing. This is F. Remaining all charges are opposite. Now apply the Coulomb's inverse scalar between the two charges. F4 is equal to K into Q square. Distance between the two charges is root 3 L whole square. Now F4 is equal to K into Q square by 3L square. That is. Next, the charge will repel to the charge of this direction. That is F. Now remaining all are charges opposite. Now apply the Coulomb's inverse scalar between the two charges. F5 is equal to K into Q square by L square. Now this is a F5 charge. F5 charges. F5 charges. Now you are seeing to this one. Next you see carefully. And F1, F5, F1, F5, F5, F1. You see, this is a F1, this is a F5. Angle between the two forces is 120. Resultant force is Fr is equal to F. Your answer is F. And F5, F1. That is the resultant force is how much? Fr is equal to F. Now, what is the meaning of this one? Now, resultant force, I'm going to write this is a F15. F15 is along which direction? Now, F15 is along F3 direction. F3 direction. F4 is equal to F5 means now you can write K into Q squared by L square. Q squared by L square. Your answer. Next, F4, F3. Now, next I'm taking. This is a F4. This is a F4, F5, F2. This is a O1 and F2, F4. This is a F2. This is a F2. Angle between two forces is 60 degrees. Now, do you know resultant force? Now, 24 is equal to root 3 F. Root 3 F 24 is equal to root 3 F. Root 3 F. Root 3 F. Root 3 F means F2 and F3. Distances between two charges is F24 is equal to root 3 F. F means KQ is 4 is equal to KQ squared by 3L square. Now this is a root 3. You can write root 3 cancel each other. F24 is equal to KQ squared by root 3L square. That is your F2. Now, that direction. Now, how many forces are in the same direction? How many forces are in this direction? Now, this is a F3 force. This is a F24, F15, F3. Resulting force is equal to F3 plus F24 plus F15. This is a resultant force. So we have resultant force is equal to F3 plus F24 plus F15. Now we have to add three forces. Finally, we are getting resultant force. Okay, you see, I'm going to write in this is F1 force is equal to K into Q squared by L squared. F2 means K into Q squared by 3L squared. F3 means K into Q squared by 4L squared. F4 means K into Q squared by 3L squared. F5 means K into Q squared by L squared. This is F24 is equal to K into Q squared by root 3L squared. Next, F 15 is equal to K into Q square by L square. That is your all process. Now, what we have to do, our aim is, our target is, we have to find out resultant force is acting on any corner of the charge. Now, resultant force is F4 is equal to F3 plus F24 plus F15. Now, so what is F3 value? F3 value is K into Q squared by 4L square. K into Q squared by 4L square plus F24 value. F24 value is K into Q squared by root 3 L square plus F15. KQ squared by L square. Now, you see the three equation having common terms. Common terms should be take outside from the equation. K into Q squared by L squared common terms. In K Q squared by L squared, take out 1 by 4 plus in second equation K Q squared take out L squared take out 1 by root 3 plus K Q squared L squared take out means 1. And K into Q squared by L squared. Now, so what we have to do here, take the LCM, 4 root 3, 4 cancel, here root 3. Okay, now what we have to do here, simplify. This is a KQ squared by L squared. Now, this is a add these two equations and this one 1 by 4 plus 1 by root 3. Now you can take KQ squared by L squared. This is take LCM here 4 1 plus 4 plus 1 by root 3. You can take now what we have to do. This is your answer. Hang on, closer. Okay, now tomorrow I will continue this class. Now, after keeping in mind, your answer is resultant force is equal to KQ squared by L squared 5 by 4 plus 1 by root 3. Your answer is your answer. Okay, now tomorrow I will continue this class. Thank you.